talking about the basic Euclidean algorithm. Actually, there are two Euclidean algorithms, namely the basic Euclidean algorithm and the extended Euclidean algorithm. One is the basic Euclidean algorithm. The second one is the extended Euclidean algorithm. In this video, we will be focusing on the basic Euclidean algorithm. The basic Euclidean algorithm is used to find out the GCD, the greatest common divisors of two numbers. Let's say the two numbers are a and b. A and b are two integers, and the basic Euclidean algorithm helps us to find out the GCD, that is the greatest common divisor. For example, if a is 10 and b is 8, then in that case the GCD, the greatest common divisor of these two, is 2, because 2 divides both of them and it is the greatest divisor possible, right, which divides both of them, right. Another example could be, let's say a equals to 12, b equals 15, then in that case the greatest common divisor is going to be 3. So greatest common GCD can be a function, can said to be a function of both a and b, right. So this is what the basic Euclidean algorithms help us to find out, right. So how basic Euclidean algorithm helps us to find out this? Let us assume that always in this function GCD a comma b, a is going to be less than or equal to b, right. Okay, now the basic Euclidean algorithm is based on the fact that even if I subtract the smaller number from the bigger number, right, this number is also divisible with the GCD of a and b. Why? Because b is individually divisible by GCD of a and b, and a is also divisible by GCD of a and b. So this is in itself divisible by a and b. So we can call the function GCD for a comma b minus a if b minus a is greater than a, right. Or we can call this function for b minus a comma a, or GCD function, if b minus a is less than a. You can say less than or equal to also, right. So why is this so? Because we have assumed that a is always going to be smaller than equal to b. So this is the way we can proceed. But what basic Euclidean algorithm focused on is that even though we have to subtract a multiple times to make it smaller than a, why don't we take the remainder of b dividing it with a? So that is b modulus a. This is the remainder when b is divided with a, right. So this is what the basic Euclidean algorithm uses. So we basically need to find at every step the GCD of b modulus a comma a, right, because definitely b modulus a is going to be smaller than a itself. So we will continue finding this GCD recursively until this b modulus a becomes 0. So the GCD of a and b when this b modulus a becomes 0 is equals to the value of a, this a. So I guess you understand this part. If you are having any doubt, you can comment me so that I can solve your doubt. Okay, let's move on to the coding part. Now making a file, namely basic Euclid.cpp file, and all right, so now what we want, we have two variables a and b, right? What we want to find out the GCD of these two, GCD of a and b, right? Now we will be using the basic Euclidean algorithm to write this function. The Euclidean algorithm simply says if this a becomes 0, right, then we return b, right? Otherwise what we will do, we will call GCD, or return, we will call GCD of a b modulus with a comma a. This is what we do. Let's run this code and try to find out whether we are getting the right answer or not. Right, like 10 and 20 will be having GCD of 10. It's working fine. Let's try it out with another example. GCD of 12 and 15 is simply 3, right? So this is how the basic Euclidean algorithm works, and we will be discussing the extended Euclidean algorithm in the next video. Thank you for watching. Bye bye.